Hi, I am doing another bit for 10.4 because we want to talk about the unit circle. It's incredibly important. Um, in some classes, they will allow you to have a unit circle um, on a card so that you can use it, and that's probably what will happen. But occasionally, some professors may need you to memorize it. But I'm going to believe that you'll be able to use a unit circle. So in your book on page 453, there's a nice unit circle. Copy that on a index card, and that will help you to find all of your um, angles in radians. A unit circle, all unit means is that it has a radius of 1. So all of your reference triangles, like 30 degrees, 60 degrees, 45 degrees, you can find the sines and cosines by using the unit circle because the hypotenuse of all of those triangles is going to be 1. And so all you have to do is find the reference triangle and divide all the sides by 2. For example, if you remember your 30, 60, 90 triangle, the side across from 30 was 1, the hypotenuse was 2, and the side across from 60 was square root of 3. So with the unit circle, since that's 1, we would have to divide this by 2 to get 1. We would divide this by 2 to get 1/2, and we divide this by 2 to get root of 3 over 2. So that's where those numbers come from with the unit circle. So in number 22, it wants you to find the cosine of 3 pi over 4. Well, if you remember from the last video, the reference angle is just pi over 4, which is 45 degrees. So if we look at the reference angle pi over 4 on your unit circle, we know that the side opposite is root of 2 over 2, the side adjacent is root of 2 over 2, and the hypotenuse is 1. So our cosine would be adjacent over hypotenuse. So in other words, it would be root of 2 over 2 over 1, or just plain old root of 2 over 2. Now, root of 2 over 2 is just the rationalized version of 1 over square root of 2. So that's where we're getting root of 2 over 2. So that would be the cosine of pi over 4. However, 3 pi over 4, look how you can do it. 1 pi over 4 is here. 2 pi over 4 is the same as 90 degrees. So 3 pi over 4 would be over in this quadrant, which means the side adjacent is going in the negative direction. So your answer would actually have to be negative root of 2 over 2. So make sure you know which quadrant you're in so your answer has the correct sign. A shortcut would be to use the trick I gave you before, another stupid trig chart. In the first quadrant, all of your sine, cosine, and tangent are positive. In your second quadrant, only your sine is positive, which means your cosine and your tangent will both be negative. In this one, only your tangent is positive, so your sine and cosine will be negative. And in this one, only your cosine is positive, so your sine and your tangent will be negative. So figure out where it is by counting over. There is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And if you have your unit circle written, you'll be able to see them where they are. Okay, now number 26, it tells you if theta is 13 pi over 4, what is the sine, cosine, and tangent? So let's go ahead and figure out where this is. Now 13 pi over 4 is quite a ways around. I mean, 2 pi equals, if we get a common denominator of 4, it would be 8 pi over 4. So let's get rid of one whole circle. So minus 8 pi over 4 would leave us with 5 pi over 4. So that's the angle we're actually looking for. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 would be down in this quadrant. So we know our sine and our cosine are both going to be negative. okay? And then we can just use our sine, opposite over hypotenuse, so it's going to be root of 2 over 2. Cosine is going to be root of 2 over 2. Notice sine and cosine are always equal they might have different signs, but they're always the same magnitude, because in a 45, 45, 90 triangle, it's half of a square, so those two sides are equal. So that means these two, the opposite and the adjacent, will always be the same with a 45, 45. And the tangent is opposite over adjacent, and since they're the same, root of 2 over 2 over root of 2 over 2 is just equal to 1. All right,